Hey guys, for those of you who are not here for 3-8, we are going to be going through complex roots dealing with I, which is an imaginary number. In order to do that, I would go ahead and pause the video and do the warm-up. First do it by factoring, then do it by a quadratic formula. I think I said movie. Pause the video, whatever. So to factor this, we put it on the correct function. My bad. Start with the first term, last term, multiply those two to get the top of our little diamond there, so negative 48 x squared. Put our middle term, negative 8x, on the bottom. Factor 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, and I could keep going, but I'm not going to because I know that one of my side numbers needs to be positive and one negative to multiply together to give me a negative. Because they add together getting me a negative, I know it's going to be my larger number. So the reason I can stop is that negative 12 and 4 add up to negative 8. So I put those in the remaining boxes. And then I factor out a greatest common factor from any row or column. I'll start here. Most I can take out of there is an x. So I take the 3x out here at the bottom. 3x times negative 4 gives me negative 12x. X times 4 gives me 4x. And then 4 times negative 4 gives me negative 16. So I'm good to go there. So my factored form, y equals x minus 4 times 3x plus 4. Because this is because we're finding the roots, I'm going to put a 0 in. Fix that. There we go. Put a 0 in for y and set each part equal to 0. So x minus 4 equals 0. 3x plus 4 equals 0. And then solve. So this one's going to give me x equals 4. This one may take a few more steps for many of you. Divide by 3. So we get x equals negative 4 over 3. Those are my two answers. Many quadratics are factorable, many of them are not. So for the quadratic equations that can't be factored, we use the quadratic formula. And that is assuming that the quadratic is in the form y equals ax squared plus bx plus c. Please take note that a, b, and c are simply the number in front of the x squared, in front of the x, and by itself. When we plug this into the formula, the x squared and the x don't go into it. So that formula, and you want to make sure you have this down, is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So we're going to take a look at that problem from the warm-up. Excuse me. 3x squared, so a equals 3. B equals negative 8. Make sure those negatives stay there. And c equals negative 16. So I'm going to plug that into the formula. X equals negative 8. And what I would highly recommend is that when you plug it into the formula, you put everything in parentheses exactly as it is. The reason for that is if you try to simplify before you put it in, a lot of times negatives get missed. And all divided by 2 times 3. And then we simplify. So what I would do on this part when you're simplifying is take everything under the square root sign, but not the square root sign, and put it into your calculator. You can certainly simplify it without the calculator or just using basics on the calculator, but there is a lot less room for error if you plug it into your calculator exactly like that. So what I would say, so that's where I would plug that in. Make sure that you keep the parentheses around it, especially if your b is a negative value, but generally just keep all your parentheses exactly the way that they are. One thing I would caution you against is putting the square root over this in the calculator. Don't do that, because we're going to get into non-real roots, which means that if you put the square root sign over it, you may very well get just an error notice, and it won't give you the number under the square root sign, and you do need that for the stuff we're going to be doing today. So now we have x equals, we're going to simplify this double negative 8 to just be positive 8 plus or minus the square root of 256 divided by 6, the 2 times 3. That equals 8 plus or minus 16, all divided by 6. And at that point, I'm going to shrink, whoops, not what I meant to do. I'm going to shrink the little calculator thing over so I have more space. At that point, you're going to split it into a plus, so 8 plus 16 divided by 6, which is 24, which equals 4. And then I'm going to do the same thing, but I'm going to do minus, so 8 minus 16 divided by 6, which equals negative 8, divided by 6, which is negative 4 over 3, which is exactly what we got from our original problem. So, all right, I screwed something up on this one. I don't know if this is going to make the whole video weird, but what I would do on this one is attempt to do the problem on your own with quadratic formula, not factoring. This isn't going to come out as a weird one, so pause it and give you a minute to do that, and when I come back, which will just be a second, all the work will pop up. So what we have here is our b values plugged in, our a value, our c values, simplified down, follow that whole thing, square root of 121 is 11, do the plus up here, negative 7 plus 11 divided by 6, 2/3, and minus 11 is negative 18 over 6, which is negative 3. So those give us our roots. They don't directly give us our factored form, because our factored form is not going to be, sorry, trying to talk and write at the same time. A lot of people have a tendency to do x minus 2 over 3 times x plus 3. The problem with that is if you multiply this out, x times x gives you x squared, and what we have up here is 3x squared. So what we can do when we've used the quadratic formula to find the factored form is to set each root equal to x and then get it all equal to 0. So we multiply, like the 2/3 equals x, we multiply each side by 3. So we have 2 equals 3x, or x times 3. Subtract 2, and so we end up with 0 equals 3x minus 2. So 3x minus 2 is one of our factors. If negative 3 equals x, then all we got to do is add 3. So we have x plus 3 for our other factor. So our factored form is 2x, whoops, just kidding, 3x minus 2 times x plus 3. So, not everything has real roots. If we were to draw this parabola, this would be, sorry, really bad thing there. On the y-axis would be super high and skinny, and it wouldn't have any real roots. I'm going to erase that because it's just hideous. But we can still, now that we know what we do from last class, set it equal to 0 to find the roots, because y always equals 0 on the x-axis, and then just solve algebraically. So minus 48, because this is a partial quadratic. We don't need the quadratic formula. We want to divide by 3 there. So we have negative 16 equals x squared. At that point, we're going to take the square root of both sides. So negative 16, or square root of negative 16 equals square root of x squared. Of course, we know that the square root of x squared is just x. Square root of negative 16, up until yesterday or last class, we'd been just doing no solution. But now we know we can split the square root of negative 16 into the square root of 16 and the square root of negative 1. That's helpful because the square root of 16 is 4, and the square root of negative 1 is I. So what we have here, and this, by the way, is a plus or minus when we take the square root, when we use the square root to solve an x squared, plus or minus 4i. So that gives us the imaginary roots on this factored form. So that means that if we had factored form, it would be x minus the root, and one of our roots is a positive 4i, so x minus 4i, and then x minus the root, one of our roots is a negative 4i, so that would give us a double negative, so plus 4i. That's not right, sorry, because this is a 3. Oh, it's my bad. That would be a 3, and then x minus 4i, x plus 4i. It's not necessarily something I would expect you to know, but in case you're curious. So this next one, we need to find the roots of this one. We already know from our graph over here that because this doesn't cross the x-axis anywhere, this is not going to have any real roots. So we have to use the quadratic formula because we can't factor something that has no real roots, at least not in the traditional way. In this one, a equals 1, b equals negative 4, and c equals 5. My suggestion would be to you that you take that information and put that in the quadratic formula and use that to find the imaginary roots of this particular quadratic equation. I'm going to pause and then write down all the work for it until the very end, and then I'll explain the final answer. So I would pause the video if I were you and do the work yourself. So this is where in the past we used to write no solution, and that would be perfectly acceptable when we were in Algebra 1-2. But now we know imaginary numbers, so we're going to deal with that 4, or the square root of negative 4. We're going to split that into the square root of 4 times the square root of negative 1, and rewrite the square root of 4, which is 2, and the square root of negative 1 we now know as I, so we're going to rewrite this as 4 plus or minus 2i divided by 2. We can simplify this further because both of these are divisible by 2. 4 is divisible by 2 as well as 2i. So basically this can become 4 over 2 plus or minus 2i over 2. And each of those can reduce. 4 over 2 is 2. 2i over 2 is just I. So 2 plus or minus I. So those give us the root. Particularly because my my leading variable is leading coefficient is a 1. The same thing that we had up here. If I have the roots, then I can figure out the factored form. So that means I can write this as x minus the root, so 2 plus I, that's one of my factors, times x minus the root, which the other root is 2 minus I, this doesn't look very simplified, so what I'm going to do is take that negative, and that's essentially like distributing a -1 and distribute it in there. So I've got x minus 2 minus I for one of my factors, and I've got x minus 2 plus I for my other factor. And what we would find is that if we were to multiply that whole thing out using a 3x3 box, we would end up with exactly the same quadratic that we started with. So what you'll notice here is a few things add out to 0. The ix and the negative ix, 2I and the negative 2I. So x squared doesn't have a like term, so it's just x squared. Negative 2x plus negative 2x gives us negative 4x. I'm done with those. And then 4 doesn't look like it combines with anything until we take our negative I squared. I squared, as we know from last class, is -1, so we have negative 1, which equals a positive 1. So we add that to the 4, and we end up with... So, this last one, if you're not interested in getting highly proficient, I wouldn't mess with it, but if you are, you should do it. You want to start by using box to, factor out the 2x plus 1. And then you start with your 2x to the third. This goes back to our polynomials unit. And then your remaining quadratic that you get down here, you're going to use the quadratic formula for. So I'm going to pause, and then I'm going to put all the work up so that you can check your answer with it. And then that will be it. All right, that is it for 3-8. This would be more of a highly proficient one, and we'll have the test next class.